This is a lecture from Open Tuition. To benefit from the lecture, you should download the free lecture notes from opentuition.com.
Okay, this is the second lecture on cost volume profit analysis. In the first lecture, I went through what we meant by break-even, margin of safety, CS ratio, and whatever. But in all those examples, we just had one product that we were dealing with. Well, what the examiner did introduce into the syllabus about 2 years ago was something called multi-product cost volume profit analysis, which of course rather explains itself. The same sort of idea as before, but this time where we've more than one product. And to show you all the things that can be asked in relation to this, there's an example, example 6 on the last page of the notes. And have a quick read with me, and then we'll do lots of things on it, everything really that you could be tested on. A company produces and sells 3 products, C, V and P. The budget information for the coming year is as follows. So we're told how many units of each we're budgeting on selling. We're told the selling prices, the variable cost per unit, and to save time, we could have worked it out easy enough ourselves, but I've written down what the contributions per unit are, the selling price less the variable cost. The total budgeted fixed overheads for the year, 8,000. The same sort of information as before, but of course this business of 3 products. So we're going to do several things here, A, B, C, D, and then there's an E and an F coming at the end. First of all, it says, calculate the CS ratio for each product individually. Well, we spent enough time on this in the previous lecture, so we can write these straight down surely. For product C, contribution is $1.25. Selling price is 5, and so the ratio 1.25 over 5 is 0.25. Some people certainly write 25%, doesn't matter, it's the same, but I'll keep these as ratios, 0.25. Similarly, V, contribution 75 cents, selling price 6, which is 0.125, and finally P, contribution $2.65, selling price 7, and so the CS ratio 0.379. So that was easy enough. Bit of rounding there, but no problem. The next one says, calculate the average CS ratio, assuming that the budget mix of production remains unchanged. Now, what I mean by that is, remember the CS ratio, if you just think of one product for a minute, the CS ratio for product C is 0.25. It means that however many we end up selling, whether it's more than 4,800 or less than 4,800, it means the contribution we're going to be earning is always going to be 25% of the sales revenue. Here, though, we want to see what the average ratio is, and assuming that, all right, we may not sell the budgeted figures, it may be higher, it may be lower, but we're going to assume that they stay in the same ratio with each other. So what I mean is, if we do sell 10% more, it's 10% more of all of them. If we sell 10% less, it's 10% less of all of them. It's not just that we sell more of one, less of another, and so on. That we're hoping to sell those quantities in the question, but they might all be higher, they might all be lower. And on that basis, we're going to work out the average CS ratio. And what you can't do is a normal average. You know, what's tempting is to say, oh, well, we've got 3, why not just add them up and divide by 3? You can't do that because the overall picture, I mean, look at P. P was selling a lot more than the others. And so, if the sales of all of them do go up and down by X%, it's the effect of P that's going to be much bigger than the effect of C and V. P was selling far more units and there's a much bigger contribution. And so, again, we can't just take an ordinary average. What we're going to have to do, there's an alternative which I'll tell you afterwards, but what we're going to have to do is let's work out at the moment what the total sales revenue is, or budget sales revenue. And then later I'll work out the budget contribution and then we'll put it together. So the budget sales revenue, well, in total from C, 4,800 units at $5. From V, 4,800 at $6. And from P, 12,000 at $7. And so what does that come to? 24,000. 28,800. $84,000. So the total budgeted sales revenue is 136,800. What about the budgeted total contribution? Well, again, C 4,800, but the contribution per unit is $1.25. For V, 4,800, 75 cents. And for P, 12,000, $2.65. Move the screen a bit. Which comes to total for C, 4,800, 125, 6,000. For V, 3,600. For P, 31,800. And so the total budget contribution, 41,400. And so, before I talk more about it, the CS ratio overall, contribution 41,400 over sales 136,800. The ratio is 0.303, or 30.3%. Now, before I go any further, make sure you are clear what I've done there. Two things. First of all, that does, if you like, make sense. You see the individual ones, 0.2, 0.1, 0.379. The average, as I said before, because P, there's so many more being sold and the contribution's higher, the average will be closer to P, and it is. At 0.3, it's P that's pulled it up, so it makes sense in that way. Secondly, appreciate, I've obviously used total sales, total contribution. And we said all along, we don't wait to break even and so on. We may sell more, we may sell less. So the sales may be lower, the contribution may be lower. But bear in mind what I said earlier. We're assuming for the moment that if we do sell, for example, 10% less, it's 10% less of all of them. And so the sales will be 10% less in total, the contribution will be 10% less in total. On that assumption, the CS ratio will be 0.303, whether we sell more or we sell less. All right, let's carry on to C. C says calculate the break-even revenue, assuming that the budget mix of production remains unchanged. So as I've just been saying, if the budget mix remains unchanged, the CS ratio is 0.303, the average. So we can use that thing I showed you in the last lecture, that to get the break-even revenue, if you think back, or if you need later look back, whether there's one product or several products, I said break-even revenue, we just needed to take the fixed costs and divide by the CS ratio. Well, the fixed costs are 8,000. The CS ratio, 0.303. And therefore, to break even, we need to sell, there's a bit of rounding here, but we're not worried there, 26,402 units. I beg your pardon, break-even revenue. Ooh. If we get revenue of 26,400, we'll break even. At the moment, of course, we're budgeting on a lot more revenue, 136,800. But even if we sell less and get less revenue, we'll still be making a profit, provided it doesn't fall the total revenue below 26,400. So far, I hope so good. And finally, for this bit of example 6, it says construct a PV chart, a profit volume chart, which again we went through in the last lecture, still assuming that the budget mix of production remains unchanged. And so let's have a go. Again, forgive me, I'll be neat, but I'm certainly not going to try and be perfect. And again, I'm not sure how you can ask this these days. Now we've moved on to having computer-based exams. It's extremely unlikely she could ask for a graph. But as I was saying, same thing with linear programming. She can ask for any bit of the workings. And she could also give you a graph and check you understood it. So it is important I go through this, and it is important you practice. But our PV chart, we're going to show the profit. This time, I did mention we do this before, but this time I'm going to show it against sales revenue. Well, when we sell nothing, when the sales revenue is 0, we've no contribution, but we've still got the fixed costs. And so we'd make a loss of, what is it? 8,000. This is minus, this is plus. So we'd make a loss of 8,000. As we start selling units, the loss starts to reduce and we start to make a profit. And we'd already worked out, had we not, if I put the budget figures in, contribution 41.4, 136,800. So my revenue, let's go up to 150,000. The budget contribution was 41.4, but remember there are fixed costs of 8,000, so the profit, budgeted profit, would be 41.4 less 8,000, which is 33,400. I hope I'm right. And so, let's have that scale go up to 40,000. So let's plot it on a graph, on the graph rather. When the sales were 136,800, which is, let's say about there. Oh, no, it's going to be a bit closer. It's about there. Sorry, it's on the illustrative graph here. I'm not going to even attempt to be precise. But the profit was 33,400, which is perhaps about there. So I think you see what I'm doing. And remember, you would not be drawing it precisely anyway, even if there's any drawing. But join them up. There we go. And there's our PV chart. And again, we don't read things off the graph, but there would be the break-even revenue. Does it look realistic? Break-even revenue, 26,400. Yes, of course it does. It looks okay. So, where are we? Not much extra there. We already know how to calculate the ordinary CS ratios. Make sure you're clear how I worked out the average CS ratio. And once we've got that, the fact there are 3 products is almost irrelevant. The PV chart as before. However, we're not there yet. Look at the last bit. This time it says, assume that the products are produced in order of their CS ratios. Construct a table showing cumulative revenue, cumulative profits, calculate break-even sales revenue, and add it to the PV chart. Now, what's it getting at there? We've been assuming until now that if we did sell fewer units, that's about the 4th time I've said it, but if sales are down 10%, for example, it's 10% fewer of each of the products, but we still end up selling them in the same ratio, some C's, some V's, some P's. It's now saying, assume we produce them in the order of the CS ratios. It's saying, whatever happens, let's produce and sell the one with the biggest CS ratio first. And if we don't sell enough, at least we've chosen the one with the biggest CS ratio. And when we sold as many as we can of them, then we'll sell the next best and so on. So if you go back to the original CS ratios, by far the best was P. And so let's sell P first. And if we manage to sell all 12,000, then we'll go to the next best, which is C. And if we manage to sell, all 4,800, we'll go to the next best, V. And so let's do that and see what will happen. It says construct a table showing the cumulative, the total revenue, the cumulative total profit. So let's do it in order. The total revenue, the total profit. All right, now our starting point, of course, is when we sell nothing at all. And if we sell nothing at all, clearly we've no revenue. The profit, well, we've no contribution, but we have the fixed costs, so you've got the loss of 8,000. But now let's start selling. It was P first, and every unit of P is being sold at $7 and giving us a contribution of $2.65. And so by the time we've sold as all the P's we can at 12,000, the revenue will have gone up from 0 to 12,000 times $7, 84,000. And what will have happened to the profit? Well, by the time we sold all 12,000, we'll have contribution of 12,000 times 265, which is 31,800. But be careful, although the contribution would be 31,800, the fixed costs are still there, of course, of 8,000. And so the profit would be 31,800 less 8,000, 23,800. So that's what's going to happen if we were only selling P. And let's put that on the same graph that we had before. You start off with a loss of 8,000 if there's no units. And if all we were selling was V, as you sell more units, you get more revenue, you get more contribution. And so it takes us up to revenue of 84,000, which is, let's say, there, takes us up to profit of 23,800, which is somewhere around there, something like this. That's supposed to be a straight line. But that is just selling V on its own. As we sell more and more Vs, well, that's what the PV chart would look like. When we finish selling as many Vs as we can, Ps rather, PPP. Why have I written V? When we sold as many Ps as we can, when we sold the 12,000, then we'll start selling the one that's next best. And the next best one, I think, was C, wasn't it? Yes, C. So remember, we've already got to revenue of 84,000, but then as we start selling C, the revenue is going to carry on increasing up to what maximum? Well, it's 4,800 Cs that we can sell. It's $5 each. And so that would give us a revenue of 24,000 extra revenue. So we'd already got 84. Selling Cs takes us from 84 up to a total of 84 plus 24, 108,000. And what will happen to the contribution? We've already got the, the profit, I beg your pardon, the profit. We've already got the profit from selling all the Ps, with so far a profit of 23,800. If we start selling more Cs, extra contribution, no extra fixed costs obviously, but extra contribution, and we'll get extra contribution 4,800 times $1.25. So an extra 6,000. So what's the effect on profit going to be? It was 23,800, goes up by that extra 6,000 to 29,800. No extra fixed costs, they're already in there. So let's put that on the graph. We were already at that point, 84 and 23,800. We're now going up to 108,000. Revenue, which is perhaps about there. And the contribution's going up to 29,800, which is perhaps about there. There. Now again, it's not accurate, but I hope you're clear where these figures are coming from. The profit doesn't go up as steeply because the contribution per unit of C is a lot lower. But the profit's still going up. It's just that we're selling them in this order, P first, then C, and in a second V. So let's finish it off. If we have managed to sell all the Cs, Then we'll go to the last one, which is V. We've already got 108,000 revenue. How much extra will we get? V, 4,800. That's $6. Gives us an extra 28,800, which takes the total therefore up to 136,800. And finally, how much extra profit? Well, it's the extra contribution we earn from the 4,800 units at 75 cents is 3,600, I think. And so it takes the total profit up to 29,800 plus 3,600, 33,400. At that stage, we're selling everything. Well, of course, we already knew those figures. This just confirms we're correct. Surely, whatever order we're selling them in, if we end up selling the full quantity of all of them, did we not already know that at revenue, where was it? Revenue of 136,800, the profit would be 33,400, which was there. And so there finishes it. Now, I apologise for it being such a messy chart. And I forgot to do these, as these should have been dash lines to distinguish, but that's trivial. But I hope you can see what's happening. What will be the benefit of doing that? Although if we do manage to hit budget, it makes no difference. You know, we're selling the full quantities, we're making the same profit. If we're given that the most important thing of all is that we at least are profitable, surely by selling P first, we're able to achieve break-even sooner. You see, break-even, if they were all sold in the same ratio, is there. I can't remember what the figure was. But if you're selling P first, we break even sooner. And as a matter of interest, what would the break-even be? Well, since the break-even here is when we're selling only P, surely the break-even at fixed overheads will be 8,000. To get break-even, divide by the CS ratio for P. And the CS ratio for P was 0.379. So the new break-even, 8,000 over 0.379, would be revenue of 21,108. Look back yourself, I think break-even was 23,400 when we were selling them in the same ratio. Selling P first will get us to break even sooner, and in that sense would be preferable. So there you are. There are limitations to the whole of CVP analysis, and particularly to multi-product, but they're listed there. In CVP analysis, we always assume the selling price per unit stays constant. Of course, think back to pricing. To sell more, we may drop the price. If sales revenue is not constant, we've not got one straight line. And similarly, variable cost per unit remains constant. You know, everything we've been doing is assuming it's linear. The total fixed costs remain constant. And of course, that the level of production is equal to the level of sales. I don't know if it's occurred to any of you, but right back from the beginning of the first lecture, we always assumed that the production was the same as what we were selling, that we're not keeping inventories. You know, because of inventories, clearly there may be reasons to produce more than you sell them, try and sell them next year. No, we assume not. I personally find multi-product a little bit silly. I mean, it's fun arithmetic, it gives you more to do, obviously. But if we don't sell what we budget on selling, why is that going to happen? It happens because customers don't want what we expect. Presumably our budgeted figures of 4, 8, 4, 8 and 12, that's based on what we think customers are going to demand. And fine, they might demand less, but surely it's not our choice as to whether they want less P's or less C's or less V's, whereas what we've done assumes we choose that we will sell P first, C second, V third. Well, I'm not so sure that's actually very practical. However, it's not for me to argue with the examiner, obviously. You've got to learn it, do what you do. So off you go. As I say, at the end of every lecture, look back if I said something too fast, you're not sure, or you need to check again. Otherwise, have a go at the practice test and see how you get on.